Welcome to Night Owl Cinema and Online DVD Rental. In this video we want to show you our approach of integrating the data schemata of two different online DVD rental services and one cinema operator. At first you will see the initial data schema of each respective company. After that, we will show you how we developed the mediated schema for Night Owl Cinema and Online DVD Rental. Next, you will get an overview of the actual integration using Pentaho data integration. And at the end of this video, we will show you some sample queries using our new mediated data schema. On the following slides you will see some ER models. Not all attributes of the actual models will be shown to improve the readability. So, let's start with Group 15. Group 15 represents an online DVD rental service. They store their movies in their movie entity, which is related with at least one standard content disc and may be related with bonus content discs. As soon as a customer requests a movie, an item is created and gets connected with a customer and a movie. As soon as a copy of this movie is available, the item gets a relation to the copy, and by this the movie is rented. Group 17 represents a cinema operator. They store their movies in a movie entity as well, but with the difference that there is an additional movie version entity. Movie holds all general information of a movie, whereas movie version stores the specific versions like director's cut or 3D version. Screening represents a screening of a movie, which may be a standard screening or a special movie night. In addition to that, the cinema halls, tickets, and seats each are represented in their respective entities. Group 18 is the second online DVD rental in our scenario. Movies are stored in the movie entity and may be related to some extra entity items like 3D or director's cut. All language tracks of a DVD are realized by relations to the language entity. If a customer requests a specific movie, a wishlist item is created. As soon as a copy of this movie is available, a loan is created and gets connected to the wishlist item and an order item which may contain several loans of a customer. After you got a short overview of the individual models of each group, you'll now see how we developed our mediated schema. At first, we combined the two DVD rentals as they have the most overlap. This again is the ER model of Group 15. The movie entities of both groups are quite similar, so we can keep them. Instead of using explicit disk information, Group 18 uses an extra entity. In addition to that, Group 18 stores language information. So we add both features and change the bonus content disk cardinality. The copy entity is used the same way by both groups as well as the customer entity. A bigger difference can be found inspecting the item entity. Group 18 doesn't have such an entity, but a combination of wishlist and loan entity corresponds to an item entity. As there is a 1-1 and 0-1 cardinality, we can simply merge both entities, get one item entity, and don't lose any data. In addition to the model of Group 15, Group 18 has an order entity. We simply add this to our mediated schema by changing the cardinality to 0n instead of 1n. Having combined the two DVD rentals, we now add the cinema operator to our schema. This is the ER model of Group 17, the cinema operator. The only overlap to the DVD rentals can be found in the movie and movie version entity. So, let's take a look at the DVD rental realization. As you can see, there's just a movie entity. This entity is semantically closer to the movie version entity of the cinema operator than the movie entity. The cinema operator thought of movie as a rather abstract concept of some original content with an explicit variation, the movie version. To combine both models, we simply split the movie entity of the DVD rentals into movie and movie version. Movie will contain attributes like the original title and the IMDb ID, whereas movie version is the explicit variation used for relations to screenings and DVD rentals. Now we have to adjust the relations and are finished with the creation of our mediated schema. So, let's get an overview of what we created. This is the mediated schema of Night Owl Cinema and Online DVD Rental. In the center, the movie version entity is located. Group 15 uses the entities and relations shaded in yellow. The red shaded part represents group 18, and the blue part is used by group 17. The mixed color regions are used together. After creating the mediated schema, we developed our ETL processes using Pentaho data integration. This is our main job, starting point for all further ETL processes. At first, we check if all connections to the source and target databases are available. After that, we extract, transform and load all our entities and relations step by step from the databases of their respective groups to our mediated database. Let's take a look at the ETL extra job. This job is divided in the two jobs ETL extra 18 and ETL extra CSV. Only group 18 uses the extra entity in their data schema, so we only need one job for them. The CSV job inserts a 3D item into the extra table because the former attribute whether a movie version is in 3D, used by group 17, is now modeled as an extra. Let's take a closer look into the ETL extra 18 job. Here you can see our approach to prevent duplicate entries by using a fuzzy match with the mediated database when loading new data from the extra table of the database of group 18. After loading the extra data, the ETL language job is triggered. This job is quite similar to the extra job just shown. So let's take a closer look at the next step, the ETL bundle movie job. In this job, the movie and movie version information are getting integrated, as well as the extra and language associations. Let's take a closer look at the ETL movie job. All groups are using the movie table, so there are 3 jobs, each for one group. Looking into ETL movie 17, you see one of our innovative features. In the top row, we are using a web service via REST client to get the IMDb ID and original title of the movies extracted from the database of group 17. Only group 18 has already stored the IMDb IDs in their own data schema, and by using the web service we can improve comparability of the movie entries to avoid duplicate entries. Depending on whether an IMDb ID was found, we do a lookup if a movie is already in our mediated database, and if so, update the original title of the movie we got via web service as well as the movie ID used in the database of group 17 into our movie table. If the web service did not find an IMDb ID or the IMDb ID was not found in our movie table, we do a fuzzy string match with our mediated database using the movie title for comparison. If no movie was found, we execute the mediated movie 3 insert update. If a movie was found, we have a last distinction, whether an IMDb ID was found or not, and do an insert update afterwards. The ETL movie 15 job is a little bit more complex as we divide the movie entries of group 15 into movie and movie version entries. First, we load the movie data of group 15. After that, we insert update the relevant information for movie version into the mediated schema. We look up if the movie version is already connected to a movie, and if not, we do a fuzzy match whether the same movie is already in our database. If the movie was found, we update the relation to the movie table and are finished. If the movie was not found, we use the REST client to receive the IMDb ID of the movie. If no IMDb ID was found, we add a movie item to our database and update the movie version relation via insert update. If an IMDb ID was found, we do again a match with the movie table, but this time using the IMDb ID. If the IMDb ID is already in our database, we simply update the movie version relation. Otherwise, we first add the movie to our mediated schema and then update the relation. The ETL movie 18 job is quite similar to the ETL movie 15 job, with the difference that we don't have to look for an IMDb ID but search for the title of the IMDb ID given by the data of group 18. This movie title can be stored as original title in the movie table. The ETL movie version job is only used by group 17 as only the cinema operator has a movie version table. Let's take a closer look. The movie version data gets extracted from the database of group 17. After that, we do a stream lookup to the mediated movie table to get the right association using the old movie ID of group 17 that is stored in the mediated schema as well. After that, we use a filter to check if a movie version has a dubbed language. If so, we're using a fuzzy match to get the right language ID from the language table. In the schema of Group 17, the dubbed language was stored as a string attribute. In the mediated schema, it's now a foreign key to the language table. In the steps ETL extra associations and ETL language associations, we are restoring the respective associations to their movie versions. The ETL customer job is a good example on how we managed the challenge of multiple runs of our ETL job. The customer table is used by Group 18 and Group 15. Let's take a closer look into the ETL customer 18 job. We are extracting the data from the database of Group 18 and then do an insert update. If we open this insert update, you can see that we look up the customer ID 18. This is the ID used as primary key in the database of Group 18 and is stored as an additional field in the customer table of the mediated schema to provide this lookup functionality to make sure that we don't get any duplicate entries. After the ETL customer job is done, the ETL order job processes the order table of Group 18. Next, the copy tables of Group 15 and 18 are getting transferred to the mediated schema, and after that the disk data of Group 15 is getting processed. Let's take a look at the ETL item job. Again, only the DVD rentals used this table. Group 15 already used the item table in their old schema, but Group 18 has to transform their wishlist and loan table entries into item table entries. So, let's take a closer look at this. First, we load the wishlist data and look up their respective movie version and customer relations. After that, we do a merge join with the loan table to get the loan information and do a merge join with the order table to retrieve the send date. For these merge joins, pre-sending sorting is necessary. After that, we look up the order and copy associations and finally put our item entry into the database. At last, we process all tables only used by Group 17, the cinema operator. This is done in the ETL bundle cinema job. After that, we finished our ETL main process and all data from the three groups is now located together in the mediated schema. Now that we have all data in the mediated data schema, we can do some sample queries. A first very easy one is a simple list of all movies stored in the movie table. This is done by a simple select statement. Let's have a look at the output. As you can see, it's a simple list of the original titles of our movies. The next query is a little bit more complex. We want to find out the most loaned DVDs. This is done by selecting from the item and movie version table and grouping by the movie version. Let's see the output. Der Pate is the most loaned DVD. The next and last query compares how many rentals were done and how many cinema visitors saw a specific movie. In this case, not all movie versions are getting compared, like in the last query, but all entries of the movie table will be listed. Let's see the output. Looking at The Godfather, which is the original title of Der Pate, there are the 2 DVD rentals we already saw on the last query output and 5 cinema visitors. So, this was our short presentation on how we integrated the data schemata of 2 different online DVD rental services and 1 cinema operator. Thank you for your attention.